Hello, dear friends, welcome back to Math with Amala. In this part number 7, we are going to deal with exercise 1.2 of grade 12, chapter 1 Relations and Functions. First question, show that the function f from r star to r star defined by f of x equal to 1 by x is 1 1 and 1 2, where r star is the set of all non zero real numbers. Is this result true if the domain r star is replaced by n with codomain being same as r star? So let's write the non-zero real number set as R star. We have two sets. We have the same set as domain and codomain, and the relation here is, or the function here is 1 by x, f of x equal to 1 by x. Let's check the 1 property here. F of x1 equal to f of x2 is the supposition. Then 1 by x1 is equal to 1 by x2. This implies that it's reciprocal x1 equal to x2. Hence, it is a 1 1 function. To check whether it is on to, let's take f of x equal to 1 by x. Since f of x equal to 1 by x, this f of x can be written like y, then y is equal to 1 by x. Here this x can be written like x equal to 1 by y, then f of x or f of 1 by y is equal to 1 by 1 by y, then you can take it as y. This implies that this function is having both an image and a pre-image, hence we can say that it is an onto function. Now let's move to the next question. It's the second one. And we have one more case here. We have to consider the domain set as n instead of r star. So in that case, if we take f of x1 is equal to f of x2, you will get that f of x1 is actually 1 by x1 and f of x2 is 1 by x2, where the xi's are from the natural number. So you can take it like n1 and n2. Then 1 by n1, 1 by n2. Hence we can say it is 1, 1. Okay, so we can say that the set, when even after taking the domain as different from r star to n, you are getting that function as 1, 1. In order to check the onto, let's take a function which is f of x equal to 1 by x, and the domain should be n. Okay, instead of r star we have to replace it with n, with codomain being same as r star. So if we take a 1 by x, there is no pre-image on the domain set, because the domain set contains the natural numbers, but it doesn't contains any numbers like 1 by x. So 1 by 4 is not there, 4 by 3 is not there in n. Hence we can say that n is not onto that function which is defined from n to r star is not onto. Now let's check the second question with the table. Check the injectivity and surjectivity of the following functions. We have to check the injectivity and surjectivity of the following functions. So the first question, f from n to n, f of x equal to x square. It is injective because for every x value there is an x square, hence it is injective, but it is not surjective because if we take a 3 belongs to the capital N, there is no pre-image for that particular value because 3 is not a perfect square of any number in the capital N set. But it is possible if we take any other set like R. Okay. Next, f from z to z defined by f of x equal to x square. It is not possible because f of 2 equal to f of minus 2 equal to 4. Both numbers are having a common element or common number as the answer in the image set. Hence, it is not injective. To check the surjectiveness, we can take a minus 3 belonging to set, which is not possible because there is no number like f of that number is equal to minus 3 in the set. Now let's take f from r to r, where f of x equal to x square, the same value, the same function with different domain and codomain. It is not injective because we can give the same reason as before for the z values. Next, minus 3 also you can take for the surjectiveness. It is also not possible here. Now f from n to n, f of x equal to x cube. It is possible because you can take any x value and its cube is defined. Hence we can say it is injective. Then the surjectivity is not possible since for belongings to n doesn't implies there exists a particular x. Next, f from z to z, f of x equal to x cube. This is also possible with the previous n property. Hence injective, but not surjective for some values like 4. Next question, question number 3. Prove that the greatest integer function f from R to R given by f of x is equal to greatest integer x is neither 1 1 nor on 2, where greatest integer denotes the greatest integer less than or equal to x. Here you have the function like f of x equal to greatest integer function. Now the domain and codomain are same with real numbers. Let us take f of x is equal to greatest integer x, then assume f of x equal to 1, then f of x1 comma f of x2 equal to 1 for 1 less than or equal to x less than or equal to 2. Okay, so whatever be the number we are taking from 1 to 2, you will get f of x1 and f of x2 is equal to 1. Hence it is not 1 1 function. Now let's check the onto function, whether it is onto or not. If we take an f of x, then you can't have 0.3 as f of x because there doesn't exist an x belongs to R such that f of x equal to 0.3. Question number 4. Show that the modulus function f from R to R given by f of x equal to mod x is neither 1 1 nor onto, where mod x is x if x is positive or 0 and mod x is minus x if x is negative. So this is the normal modulus value, modulus function. So let's define mod x equal to x or 0 if x is positive, then which is equal to minus x if x is negative. Or in other words, we can say x when x greater than or equal to 0 or minus x when x less than 0. Actually, here the values are moving to the positive side, whatever be the number inside in the x value. F of minus 1 is 1, f of minus 2 is 2, f of 1 is 1, f of 2 is 2. Here you got f of 1 and f of minus 1 are same, which doesn't implies that 1 equal to minus 1, hence it is not 1 1. Now you can check the ontoness with some number from the domain set and codomain set. Let's take f of x equal to mod x. This is actually a non-negative value because modulus function makes the function into a positive value, hence it is not onto, since we can't find a particular preimage for a particular number. Okay, hence it is not onto. Fifth question, show that the signum function f from R to R given by f of x equal to 1 if x greater than 0, 0 if x equal to 0 and minus 1 if x less than 0. You can change it to minus 1. So you get that for x greater than 0, whatever be the number we are taking as 1, 2 or 3, f of 1 is equal to f of 2 is equal to 1 always. Okay. So since it is a greater than 0 case, you get that f of x1 is equal to f of x2, but it doesn't implies that x1 equal to x2. So x1 is not equal to x2, which means it is not 1 1. The function is not 1 1. Let's consider the codomain set with 1 0 minus 1. The codomain set contains some more elements other than this 1 0 and minus, but there is no particular pre-images for the elements which are other than 1 0 minus 1, hence it is not onto. Sixth question, let a is equal to 1 2 3, b equal to 4 5 6 7 and let f is equal to set 1 4 2 5 3 6 be a function from a to b. Show that f is 1 1. Here f of 1 is 4, f of 2 is 5, f of 3 is 6. So 1 is having an image, 2 is having an image, 3 is having an image, hence it is 1 1. Since all the elements in the domain has an image, it can be called like 1 1. Question number 7. In each of the following cases, state whether the function is 1 1 onto or bijective. Justify your answer. So the first case, f from R to R defined by f of x equal to 3 minus 4x. Here f of x1 is equal to f of x2 implies 3 minus 4x1 is equal to 3 minus 4x2. You can cut the 3's from both sides and minus 4 also can be cut from both sides. You will get x1 equal to x2, hence it is 1 1. In order to check the ontoness, let's take f of x equal to 3 minus 4x. Then y can be written like 3 minus 4x, x equal to y minus 3 by minus 4. You can cancel negative from both numerator and denominator. You will get 3 minus y by 4. Go through these answers and try to write them as you are on. Please stay tuned for the next video with upcoming questions.